Good morning, dear students. Good morning, all of you. How are you all? Fine. Okay, dear student, this is a video of class 11, and in this video, we are going to talk about the substituted benzene compounds. And you know that benzene, what would be the formula of the benzene? You can see C6H6 is the benzene, and if anyhow I will remove this one hydrogen, so it will become C6H5 and one bond will be vacant. Okay now, so if I will remove one of the hydrogen, then I can add something, some X, that means halide, some OH, some NH2, okay na, chlorine, anything we can attach after removing one of the hydrogen. So that can be called as the substituted benzene compounds. Okay na. So here I have taken one of the one of the benzene in the molecular formula, and you can also write that in the benzene structural formula, that means aromatic compound, benzene cyclic compound you can write, and you can understand that one. So here cyclic compound of benzene is 3 4 5, and at the alternate position you have to give one bond. Okay now, alternate position bond would be there. Okay, now you can see just like here. Okay now, just like here, this one. Okay now, at the alternate position one double bond would be there, and we can actually remove one of the hydrogen from this position, because everywhere in this one CH is there, everywhere, at every point, at every joint, one carbon and hydrogen is there, that you can see in this one, at every joints one carbon and hydrogen is there. So one hydrogen I have removed from that one, and I will attach one of the group, and here in this case you can CS3 is there, in this case OMe. Me is what? Me is CS3 methyl. Okay na. So OCS3, this one can be called as a anisole. You can see the common name of this one, it is written. So you can see this one, that yes, from the benzene, after removing one of the hydrogen, we can derive our substituted product. Okay na. So that is, you have to understand, and then you can write the name also. Its common name can also exist. Okay na. Its IUPAC name can also exist. So here in today's video we will talk about all these part. Okay na, what has been given over here, that substituted benzene compounds, we will talk about this one. Here you can see, first of all, this one you can see that benzene is there, this cyclic part is benzene. After removal of one of the hydrogen, I have attached one group, that group is CS3, and that will become, that will call by a common name, and that common name is toluene. Here it is given toluene. Okay na, it is written toluene, but the IUPAC name that you can also call CS3 is alkyl group, and one carbon would be there, that means methyl, and this one is a benzene. So what it can be written? Methyl benzene also. You can write methyl benzene. Here you can write methyl benzene. You can see here it is clearly visible, methyl benzene. But if it is, you have taken this is your benzene, you have removed one hydrogen from this position, and if you will add OMe, that means this one can be called as anisole. This, if I will remove this Me, and if I will write CS3, then this one can be called as OCS3, benzene OCS3. So this one would be the anisole, and also called as methoxybenzene, then after you can say this is a benzene, and I have removed one of the hydrogen, then substituted benzene compound will form, and here NH2 aniline would be there. Sorry, as I have removed, one NH2 group came, and its common name is aniline, and aminobenzene we can NH2 RNH2, that one is amino and its name is benzene. So it can be called as aminobenzene also. Okay, now you can see now the second one here, benzene. And if I will remove one of the hydrogen, if I will remove the hydrogen, one hydrogen from here, and NO2 I will use, then this one be called as a nitrobenzene. Then after one hydrogen I have removed, bromine I have added, bromo I have added. You cannot add bromine, you have to write with the bromo, chloro, okay, na, fluoro. So bromo, and this is benzene. So just like its name is bromobenzene. Okay, if you are seeing here, it is has given, if benzene ring is disubstituted. Disubstituted means what? From the two position, disubstituted means what? From the two position, hydrogen is actually removed. Hydrogen is actually removed from there. So you have to add two functional group. Bromine would be there, chlorine would be there, whatever, it's your choice. Okay, now so in this case you can say from this position, from this position I have removed hydrogen from this position. So if you have removed one hydrogen from each position, you have to satisfy the bond of the carbon. So you have added bromine at this position. So now you can give the positioning. One bromine you can count from here also, then this would be two bromine. Okay, now then you know this is a benzene. So at 1 2 position, though two bromines are there, so what will you write? 1 2 dibromo and benzene. 1 2 dibromo benzene. Then after you can see here I have taken 2 3. Okay, now 3 positions. So you can how can you can count the bromine, number of bromine from here also, 1 2 3. Okay, now, or you can count from here also, 1 2 3, that both of the bromine will come at the same position. Okay, so what is the name? 1 3 dibromobenzene here. Then after 1 4 dibromobenzene. Now you can see, if your main group is here, present here, and at first position some group is coming, some functional group is coming, that position is known as ortho. That position is known as ortho. If first position not anything is there, at second position is coming, then it is called meta. And just vertical, you can see first one at the top and just second one at the bottom, 1 4 position, that can be called as para. So you can remember 1 2 position, 1 2 position ortho, 1 3 position that is meta, and 1 4 position that is para. Okay, now so it has given over there, and the name you can write similarly. Okay, then after we will talk about substituent of the base compound is assigned number 1. Here you can see, here I have written this compound, I have to write the name, and here you can see benzene is there. At 3 position, 3 functional groups are there, NO2, NO2, Cl. So you can, from where you will start writing the positioning. Chlorine you will give the priority, or nitro you will give the priority. And alphabetical, you know na, how to write the alphabetic IUPAC name, so alphabetically. So it is sure that chlorine will come at first place, but you will start from here 1 2 3 4, or you will start from chlorine 1 2 3, this carbon 4. From where you will start counting. So you should understand the counting should start from chlorine. Okay, na, that halide will give the first priority. You will give the first priority to halide, and then its name would be 1 chloro, and at 2 and 4 position nitro is there, so 1 chloro, 2 4 nitro, and this one is benzene. Okay, now you can see here it has given, this is slightly more complicated than that one, because here you can see NO2 is also there, CS3 also there, chlorine also there. So from where you will start giving the positioning. So listen and remember that thing. If chlorine is present and nitro is present, nitro group is present, you will start counting from chlorine. And if methyl is there, then you will give the first priority to methyl. So counting will start from 1, first methyl group, 2, 3, 4. Okay na. So what would be the name? 2-chloro, alphabetically chlorine will come first. 2-chloro, 1 position methyl, and then at 4 nitrobenzene. Okay na. So this is the name. And you know OME is what? OME is, here I have discussed now, OME is anisole. OME is anisole. So you can see here the name is given. How can I write the name? Here for this one, you can see for this one, 1 methyl is also there na, and here is also methyl. So which methyl you will give the first priority? From where the positioning will start? Positioning would start from this anisole, OME. Okay na. OME or methyl would be present, then you have to give the first position at OME. 1, 2, 3, 4, but the alphabetically 2-chloro would be there, then after 4 methyl, and then it is the whole compound is anisole. Okay na. Then after this one is the same also. Here you can see this one is ethyl group, this one is ethyl group. So 1 amino, 2, 3, 4, 4 ethyl, alphabetically 4 ethyl, 2 methyl, and then after aniline, RNS2 is the aniline. Okay na. And then after this is the last one, you can see methyl is there, alcohol is there, then we will give the priority to alcohol. 1, 2, 3, 4, 5, 6, and you can see 3, 4 dimethyl, and this OH, if it is present into the benzene, then it will call as phenol. Okay na. So 3, 4 dimethyl phenol would be the name. Okay na. So that's it for the substituent. Okay, thank you all of you.